Right, this is physics A-level measurements and their errors. This is going to be the key notes, so I'm going to make like individual flashcards for each part, and I'm going to explain them as I go along because I feel like that's a good thing to do. So that's what we are going to do if this chooses to load anytime soon. Oh, cool. So the first part is the base units. So these are SI units. Stands for standard index. Okay? So what you need to know, there are 7 SI units. These units can be used to make other units, e.g. stuff such as joules. Yes. So what they are is mass is kilograms, there is time, which in seconds, light intensity, which is in candela, there is chemical substance, which is in moles, there is length, which is in meters, there is current, and this is in amperes, and there is temperature, and this is in Kelvin. So this is basically the first part. This is what you need to know. It's a standard index, and it's, well, there's 7 of them obviously. These units can be joined together to make other units, and these are the ones. You need to know all 7 of these. The next one, SI prefixes. These are like the things you use to convert to and from different versions of a unit. So what that means is basically, say you had 1 second and you want to convert that to 1 millisecond. Lovely. You love it when this happens, don't you? So when you want to convert it to 1 millisecond, what you would do is you would do 1,000 milliseconds, because 1,000 milliseconds is a second. So that is the question, and now the ones you need to know. So you need to know T, which is tera, and that is 10 to the minus 12. 10 to the 12, sorry. Tera giga, and that is 10 to the 9. And then there is mega, which is 10 to the 6. Then there is kilo, K, kilo, which is 10 to the 3. C, and that's centi, and that is 10 to the minus 2, and then it literally just goes back up again, so it loops. So M milli is 10 to the minus 3. M micro, I can't do the symbol, is 10 to the minus 6. N nano is 10 to the minus 9. And then there's P, pico, is 10 to the minus 12. And then F, femto, which is 10 to the minus 15. Beautiful. So that is the second set of flashcards, and that is for the SI units and the SI prefixes. So now here is set, well, the third one. So this one is under the value of significant figures. So these are commonly used to be able to help with human interpretation of values. This would be due to the fact that the more simple a quantity is, the more likely there is to not have a mistake in calculations. E.g., so say you had the number that, and then obviously that is not very pleasing, but the number 27 and then is a lot more pleasing. So significant figures are normally just used to be able to help understand stuff better. And in physics, always use two significant figures. That's not how you spell figures, but it's cool. So that is a significance figures one, and there it is. So next, when you're doing experiments, there are a few key terms you need to know. So key terms for experiments. So I'll explain what all of these are and like definitions, etc. So first of all, random error. This is an error which does not follow a pattern. This is an error that does not follow a pattern. That means that, like, say, it would differ, well, the values would differ due to unpredictable circumstances. The random error cannot be corrected, but by doing multiple readings and then a mean / average, they can be removed, and that's to an extent. So random errors are basically, say, like parallax vision, where like you measure something completely differently to someone else because of circumstances that has no fault to your own. So systematic error, an error which follows a pattern, an error which follows a pattern. That's literally it. So it is something, e.g. lack of calibration. So calibration is basically, say you have a scale, you put something on the scale that you knew was 75 kilos and it comes up with 79, so you know there's a 4 kilo difference. Zeroing the scale and getting rid of that 4 kilos is called calibration. So now precision. So we're going to make these as condensed as humanly possible. Precision, how close repeat values are. So say you did an experiment and you got 10 values, it's how close those values are to one another. Accuracy, how close the value is to the true value. So how close your measured value is to what the actual answer is. Repeatability, if the same person under all the same conditions would be able to get the same results. So say you did the exact same thing in the exact same order with the exact same stuff, would you get the same stuff? Reproducibility, if a different person under the same conditions would have got the same results. So say in the exact same condition, if a different person were to do the experiment, would they get the same thing or would they not? And then resolution. This is the smallest change in quantity and or the maximum precision. So say the resolution of a ruler is like 1 millimeter, that kind of stuff. That is basically resolution, is the maximum precision you can actually get. So now, finding uncertainties key terms. So finding uncertainties key terms. These are absolute uncertainty. This is the maximum and the minimum, a maximum minimum range that an answer can be. So say you have a table that's 430 centimeters, and then it's plus or minus 5. So the uncertainty is 5, and the absolute would be 135 to 145. Fractional uncertainty is very simple. It is the absolute uncertainty divided by the mean or the value achieved, in a way. So it's literally the mean divided by the value you've gotten, and the percentage uncertainty equals the fractional uncertainty times 100. So that's very simple, very self-explanatory. It's literally the fractional, and then you times that by 100. Next is combining uncertainties. I feel like this is probably the last one, maybe, that you actually need to know for this topic. Actually, there might be one or two more. So, combining uncertainties. So when you combine uncertainties, that's when you add or subtract them, or you times or divide them. So there's only really 4 options. So when you add or subtract them, you use the absolute uncertainties, while when you times or divide them, you use the percentage uncertainties. And as far as adding or subtracting goes, we should probably do this here. You always add, you never subtract. And when you times or divide, it does not matter what the values say. Whenever there is a variable, you add its value to the total, e.g. A plus B divided by C. The combining uncertainty would be A plus B plus C, and that never changes. So that is basically it. Okay, and this is actually the last one of this. So it is graphs. Use of graphs. So first of all, we'll get the really easy one out of the way. So that is the y-intercept. This would be used to be able to measure. I should make this bigger. Measure if there is a systematic error. This is because, like, say, obviously you had a scale, you thought the value was meant to be 0 for the y-intercept, but it's not. That's when you know you have a systematic error. So now, error bars. These are used to be able to predict uncertainties from a graph. To plot the error bars, all you do is get the range of the values you have, then divide by 2, and then to get the uncertainty, and that is percentage uncertainty, you do the best gradient divided by worst divided by best, no, that's best gradient times, no, minus worst gradient divided by best, and that is all times by 100. And I'll explain what that means. So say when you have a graph like this and this, and you have points such as, let's just take a brush and just like put point, oh for God's sake, I actually have to point, 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 and then you have error bars which go here, 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 and so on and so forth. You need to find the best and the worst gradient. So that would be the steepest and the shallowest. So for example here, the steepest gradient would be the one which would go right there, and the shallowest gradient would be the one which would go there, and this would be the best gradient, the one which would go through here. So you would do the gradient of this one, so the middle one, and that's the best. Then you do the gradient of these two, and then you would average it out, and then after you average it out, you would put it into this formula, and that is it. Thanks for watching.